we start from here, when we have a system where there is a DC voltage source and an AC signal source. So in that case, there are two signal sources present. Okay. So one thing, it is clear to you that the base current that will be flowing, it is going to have two components. One is DC, another is 10 sine omega t, which is AC. Taina? That part you understood?
Yes, sir.
Okay, fine. So if I draw the current relationship here, so in that axis our total current and in this axis our time. So since the IB is equal to 25 plus 10 sine omega t, so the maximum value of the current is 35 and the minimum value of the current is 15, and the value of the base current is fluctuating or changing between 35 to 15. So that is how it's. So in fact, it consists of two parts. One is due to the DC, another is due to the AC. Now, so next we learned how to draw the load line. Okay, so we learned how to draw the load line, and if you draw the load line, so that is the Q point. This is the load line, and the load line is intersecting many IV characteristics, and this Q point is for IB is equal to 25 microampere. Okay, so IB is equal to 25 microampere. Now, what does that mean? So when you obtain a Q point, from each Q point we get two values. One is VC, one is IC. So that's the value. VC is the value that you obtain from origin to this. This is our value of VC. For example, it is something 5.6. This value of VC is 5.6. So the value that you read of the curve, it means this is the value of voltage from collector terminal to emitter terminal. Similarly, IC that you're going to measure, which is the value of IC, if you draw the vertical horizontal line and where it intersects the IC axis, IC is equal to 2.2 milliampere. So that much it should be clear. So from each value of Q point we get two things, value of VC and IC, and VC is the voltage across the voltage from collector to emitter, IC is the current to the collector terminal. Now, and so now that our base current, we have already established our base current is not fixed. Base current is what? Base current is changing. Okay, so it is changing from 35 microampere to 15 microampere. So now that it is changing, so what does that mean? So our load line is changing. Our load line is intersecting many IV characteristics. Right? Many IV characteristics. There are IV characteristics. There is one IV characteristic here which is for 25 microampere. So you can imagine there should be another IV characteristics which is for 26 microampere, another IV characteristics which is for 27. This is how it's going. Probably I didn't draw.
Yes, sir.
Like that. Okay. So you can imagine there's a millions of IV characteristics. Okay.
Yes, sir. মানে হচ্ছে স্যার কিউ পয়েন্ট থেকে সেটা ফ্লাকচুয়েট করতেছে।
So now that this load line is intersecting many IV characteristics for different values of IB, and we already learned that IB is fluctuating between 35 microampere to 15 microampere, and then this each Q point we get two values. One is VCE, one is IC. So from each Q point, as base current is changing, the Q point is going up. Let's use different color. Okay, so the Q point is going up. Okay, and it reaches 35 microampere. When it reaches 35, and again remember, every time there is a Q point, it means there is a corresponding value of VC and IC. Again, once it reaches 35, it starts to climb down. So 35 pe uthar pore, once it has reached 35, it starts to climb down, 34, 33, this way. Okay, so it starts to climb down. Again, its starts to climb down. So from each value of Q point, we are going to get this. sorry again. So you were here. So found out that as the Q point is moving along the load line, is moving along the load line like this. Okay? As the Q point is moving along the load line, AC Q point, DC Q point is fixed. AC Q point is moving along the load line. Why? Because base current is changing between 15 ampere to 15 microampere to 35 microampere. So from each base current, we find the load line is intersecting the IV characteristics, corresponding IV characteristics, and from each IV characteristics and from each Q point, we find the value of VCE and IC. So when you connect all the points, you will find the value of VC is in fact changing, such as from 5.6 to is going down, coming down to roughly 2.5, and VC again goes to roughly around 8.2, again coming down to. So that means the VC is changing, which means if you go to our circuit, you are going to find in the output side here, you're going to see for input change, which is VV is changing between 2.1 volt, the input voltage changing between 2.1 volt to 1.3. The corresponding VC is changing from roughly কত value ছিল 3. Let's say 3.6 to 8.2 voltage. VC is changing. Okay, input signal VC is changing. Okay, something like that.
স্যার এগুলো আমরা গ্রাফ দেখে বলতেছি আর কি।
হ্যাঁ VC is changing. So তার মানে দেখেন, so VC is changing from there. So that is the thing that I finally drew. Okay, আমি শুধু এখান থেকে গ্রাফ থেকে আমি এটা আলাদা সেপারেট করে নিলাম। তার আমি কি দেখছি 2.6 থেকে 8.2 the VC is changing. Now that consists of a DC part as well as an AC part. তাই না? The DC part is 5.6 volt. Okay, so if I see VCE, it consists of a DC part VCE plus small VCE. So VC is 5.6, and this one is, let's say, something. It's a sine wave. It can say something 0. Let's say 2.2, 2.6 sine omega t. Okay, and this is the corresponding changing current. Again, the current has two parts. This one DC, which is another is AC. As the DC part is 2.2, and the AC part is, let's say 1.2, for example, sine omega t. Okay. Now, when I'm going to amplify anything, I will be considered the signal part alone. That's why I subtract the DC voltage in the following diagram. In the following diagram, I subtract the DC component. So DC component can be just eliminated kore fellam. So it's a DC component eliminated kore felle. So what we have, our signal is in fact fluctuating 2.6 to, let's say, -3 volt. So AJ 2.6 to minus volt, it is due to what? We obtained this due to the signal that we applied at the input side. We applied 0.4 sine omega t. That's why we obtained an output signal like this. So clearly, if the amplitude was 0.4 at the input, what is the amplitude at the output? 2.6. So clearly we have an amplification. What is the amount of amplification? Amount of amplification, we call it AV, which is 2.6 sine omega t, let's say, divided by 0.4 sine omega t. Okay, sine omega t চলে গেলে থাকে হচ্ছে roughly 6.5 times. So our input signal has been amplified by 6 times. That's the thing.
স্যার AV এর মানে ফুল ইয়াটা কি স্যার অ্যাপ্লিকেশন?
Sorry.
AV এর ফুল ইয়াটা কি স্যার?
AV হচ্ছে amplification voltage amplification.
স্যার এটা কি কারেন্টের ক্ষেত্রেও কিছু এক্সপ্রেশন?
It could be done as well for current. AI, it is called AI, current amplification. A
ওকে
AI. আমরা already know current amplification alpha beta, these are all amplification factor. So beta is what? IC divided by IB. If I say beta is equal to 100, that means the base current is 1 microampere, collector current would be 100 times 100 microampere. Base current is 0.01 milliampere, collector current would be 100 times 1 milliampere. So this is our current amplification. That's why you remember it's a common base current gain or amplification. That at that time they used amplification or gain.
স্যার তাহলে আলফা বিটা হচ্ছে স্যার আমার যখন ডিসি সোর্স থাকবে শুধু, আর যখন স্যার এসি ডিসি একসাথে থাকবে তখন এআই আর এভি।
In fact, you can determine AI. In fact, when you are obtaining the in for an amplification, the BGT is operating in active region. So both DC signal and as well for AC signal it is active region. ঠিক আছে? So that means you in fact when if you are going to find, let's say AI যদি বলেন IC divided by IB, so that in fact you are going to find is better. Same thing. মানে current relation
Okay.
same signal জন্য একই থাকবে. Okay, is that understood?